half power, stop for a second, then go to full power.
Okay.
I can't really see the.
All right, so in our attempt to minimize the weight of this gearbox, we're forced to sacrifice robustness. If the design's not robust enough, it fails. What you just saw fail in a most spectacular fashion was the inner shaft nose bearing. That was the smallest bearing in the design because it had to fit between the two shafts. I had concerns about it, and they were justified because it couldn't handle full power. When the bearing failed, it allowed the shaft to flex, and at full power, snapped like a twig. But design is usually an iterative process, especially if we're trying to optimize one parameter at the expense of other parameters, as we are here. Sometimes the best way to arrive at an optimum solution is to sneak up on it. The failure of the inner shaft nose bearing shows that some of the assumptions I made weren't conservative enough. So back to the drawing board we go. Since the failure happened to the inner shaft, it's pretty clear that the inner shaft is going to have to be replaced with something a little bit more robust. In this case, I've chosen to go with a piece of 1/2 inch 4130 chromoly steel with a wall thickness of 0.049 inches. The replacement of the inner shaft with a larger diameter means, of course, that the outer shaft is going to have to be replaced as well. And in that case, I decided to replace the outer shaft with a piece of 5/8 inch diameter 4130, also with a 0.049 wall thickness. And the drawing here, you can see the outer shaft laying over the top of the inner shaft. I'm going to make the outer shaft invisible for the moment, just to make things a little bit clearer on the interior of the gearbox. The problem with using 1/2 inch and 5/8 inch diameter shafts is that there's no longer sufficient room in between the two shafts, that is annular space in between the two shafts, to put a bearing. And that means I had to come up with a different mechanism for holding and aligning the inner and outer shafts, in view of the fact that we can't put a bearing in between the two. And the mechanism that I came up with for that is I'm calling the outer prop hub, and I'm going to highlight it here. And it's an aluminum fitting that has a needle bearing in the top of it. That is right in here, and the needle bearing holds the inner shaft, and at the same time holds the inner propeller, that is the reverse direction propeller. I'm going to display the outer shaft here, so that you can see that the outer shaft, that the prop hub fits on top of the outer shaft. And there's a 632 screw that will, on either side of it, that will fasten the prop hub to the outer shaft, and then the inner shaft is able to slide through the center. The propeller itself will go onto the flange on the top of the outer prop hub. Now, obviously, increasing the diameter of the shafts means that we had to increase the diameter of the outer shaft main bearing, which is this one here. And that meant that we had to redesign slightly the outer shaft main bearing holder to make it a little bit bigger. And because of the size of bearings for 5/8 inch shafts, I also elected to use a needle bearing on this one too, which is here in the center of the outer shaft hub. Now I've also decided to include a set of thrust bearings, which are going to be located down here right at the base of the outer shaft. And to make the whole thing a little bit easier to view, let me display both the top and the bottom housing. And in this view you can see that the top housing has a outer shaft upper bearing holder, which is fastened to the top of the housing, and it is what is providing the support for the outer section of the upper outer shaft, the upper section of the outer shaft. Now the idlers, which are located in this section of the gearbox, are not shown here, mostly just so that they don't overcomplicate the area. I can throw in the outer shaft main gear, and you can assume that there's been no changes, at least for the present time, to either the first or the second idlers. I went ahead and made up the new parts that we reviewed in the CAD drawings. Now I did that off camera just to speed up the whole process here. If you recall, this is the piece that failed in the last version of the design. This is the inner shaft. It's made of 1/4 inch 4130, and I elected to go ahead and replace that with a piece of 1/2 inch diameter 4130 with 49 thousandths wall thickness. The inner shaft is going to be supported by 2 bearings. This, of course, is the inner main gear. So the drive coupling is going to be driving this side of the inner shaft, and it's being supported by the inner shaft lower bearing, and the upper part of the shaft actually going to be supporting by a new part that I went ahead and fastened to the inside propeller, which is the left-hand propeller. It's maybe a little bit hard to see in there, but there is another needle roller bearing that is inside the shaft, such that the inner main bearing shaft slides through that slides through this bearing and then attaches to the right-handed propeller, or the front propeller. The outer shaft obviously has to accommodate the larger diameter of the inner shaft, so I'm using a piece of 3/4 inch 4130, and because it's bigger in diameter, it needs a different bearing setup. So this inner shaft has a lower main bearing, which is fastened to the side of the case in this fashion, and fastened with cap screws, and that holds the lower end. The upper end is supported by this is the upper outer shaft main bearing, and it goes on the top of the case like that and supports the inner shaft. It supports the outer shaft with the inner shaft protruding through it. Now, one of the things that we also need is a thrust bearing, and that is going to be located on the bottom of this outer shaft, And you can see this thrust bearing. It's a little flat set of roller bearings with stainless steel washers on either side, and they're going to be supported by this little bearing retainer cap. This has to, in order to assemble this thing, I'm going to have to put the outer shaft through this bearing and then attach this little bearing cap with a thrust bearing to it in somewhat of a semi-permanent manner. That just slides through this roller bearing like this, and I've pre-greased these things so that I don't have to spend a lot of time doing that. But I'm going to apply a little bit of 680 to this, and then we're going to put the thrust bearing set on, and then secure that with the retainer. This stuff is it's good, but a little bit goes a long way. Make sure we've got a little bit here, and I'm just going to put a very small amount of it into this inner surface, like that, and then we'll drop the thrust bearing, which has been pre-lubed, over the front of this, and then just slide this bearing retainer over it. I'll spin a little bit here to spread some of that stuff, and set this unit aside. That will take about 15 minutes or so to set. Now, one of the things that I want to point out here is that when the thrust bearing, when the thrust of the propellers pulls on this inner shaft, it's going to drive the outer shaft, excuse me, it's going to drive the outer shaft in that direction, and it's going to pull it up against this thrust bearing, and when it does that, there's a small gap that's still between the bearing support and the gear, so the gear doesn't rub on the top of the bearing. Okay, I want to point out how this little thrust bearing assembly works. Note that this is the outer shaft main bearing support, and when the thrust from the propeller pulls this outer shaft, it forces this little retainer clip here, it forces the bearings up against the bearing retainer, and that still leaves us about a 25 thousandths gap so that the main gear doesn't rub on the top of the main bearing support. So now I'm going to go ahead and install the outer shaft into the housing. I know it's a little hard to see that. But it should just screw right in there. I'm going to use just 2 screws right now because I dropped the other one on the floor. But now there's the action of the outer shaft and the thrust bearing. We'll just go ahead and drop the inner shaft now, right through the center of the outer shaft. And put the case, the bottom case on, and you can see that the main bearing for the bottom of the inner shaft is actually supported by the bottom of the case here. Now these are the same 2 idlers that we've been used in the earlier design, and they just go in and drop into these recesses that are in the bottom plate, and you have to do them correctly because you can get it upside down. Oh, that looks better. Now you can see the lower main drive gear engages with this lower part of the idler. And last but not least, we'll put the second idler in. And if I hold my mouth just right, it will drop into their bearing recess that's designed for it in there, like that. So now you can see the contra action. And it's time for the top of the case here. And this is the outer shaft upper main bearing. It slides over the top of the outer shaft. And this bearing has also been pre-lubricated, that is, I lubricated it with grease. I'm going to line up these screws and fasten the bearing retainer, the bearing holder into the top of the case. Okay, there's one other screw that goes in, so I'm going to hold off on it for a few minutes. And next goes the lower propeller. This is the left-handed propeller, and it contains the bearing that supports the inner shaft. And that lines up with a hole that's been bored in the outer diameter of the outer shaft. Now the upper or the right-handed propeller is driven by the inner shaft, but we've got to separate the movement of the outer shaft from the inner shaft, and I'm going to do that with a nut that'll act like a base for the upper propeller. I've got a little aluminum washer there to spread the load a little bit. And I'm going to tighten these with a pair of wrenches. Now in the field we can remove the propeller simply by reversing this procedure. And now you've got I've got a little bit of grease on my fingers, but you've got that contra-rotating action. And the case is going to be mounted through these 3 mounting holes, which will slide onto a mounting plate and be secured on the back of that mounting plate with a set of long stainless steel screws. And so the next step of this process is going to be testing, and we'll bolt all this together in a test rig and run it up to full RPM and see how it fares. This is recording. Say when. Just got it off of there.
Mine's ready.
Ready for juice? You're done.
Got a little bit of turn there.
You came down on the throttle that time?
Yeah, I did.
You had a rudder to that, didn't you?
Yep.
Yeah. That looked a lot better. Oh, that was
Just
nice.
cruise around for about 2 minutes at that power center.
Yeah.
That way we get some wear on
Let's
the
put some
gears.
time on it.
You gonna bring your flaps up?
That would be a good idea.
That's a big enough area to see the flaps.
How's the control of it?
If you use the rudder, it's okay.
There's one in it. Looks like it's sensitive to the elevator. There you go. Nice. Just floated in. Look at that.
Good job.
All right. Okay, that's
I don't
3
like
minutes
flying
and
other
10
people's
seconds.
airplanes, to tell you the truth. But it stayed tight that time.
Yeah.
Oh, it's got lots of power.
Now we just gotta get
I did, but it still ain't right. I'm sure I put the flaps on full too soon, and that's why it was pitching up like it was. I should have just didn't have flaps first.
Yeah.
But it's still.
Did you land with full flaps this time?
Yeah, I landed with full flaps last time.
Oh, I thought you only landed half. Okay.